Alright, this is Stephen Riley doing problem number 6, which is to graph the function y equals x squared minus 9 over x plus 5. First off, you need, because the degree in the numerator of the fraction is larger than the degree in the denominator, then you know that there is no horizontal asymptote. Second of all, to find the vertical asymptote, you set the denominator x plus 5 equal to 0. So the vertical asymptote is x equals negative 5. And lastly, to find the x-intercepts, you take the top of the fraction, or the numerator, and you factored the top, which is x squared minus 9. That factors down to x minus 3 times x plus 3. And then you set each factor equal to 0 to find the zeros, which is x equals negative 3 and x equals 3. So let's put that on our graph. We know that the vertical asymptote is negative 5. That the zeros are negative 3 and 3, and that there's no horizontal asymptote. So, next off is to plug in points to solve. So the first point we'll try is 0, which is also able to be done by plugging 0 into the original function of y equals x squared minus 9 over x plus 5. So it'd be y equals negative 9 over 5, which is right there. Secondly, we'll try negative 1, which is negative 1 minus 9 over minus 1 plus 4, which equals 8 over 4, which equals negative 2. So come out with negative 1, negative 2, and then we'll plug in point negative 4, which is right pretty close to the asymptote. So negative 4 squared minus 9 over plus 5, which equals 16 minus 9 over 1, which equals 7. So negative 4 up 7. Let's erase this. Alright, let's plug in a few more points further out to the right. Let's try plugging in point 6. So 6 squared minus 9 over 6 plus 5 equals 36 minus 9 over 11, which equals 27 elevenths. And that is roughly right there. One more point should be good, and we'll plug in 10. So 10 will be 100 minus 9 over 10 plus 5, which is 91 over 15, which is roughly 4. Just a little bit over. So the first side of this graph looks somewhat like this. Alright, we'll continue plugging points in past the asymptote. We'll start out with -9. So -9 squared minus 9 over -9 plus 5, which is 81 minus 9 over -4. Which equals 72 over 4, negative 72 over 4, or 72 over -4, which is also -18. So now you know that -9 is -18 on this graph, which is roughly right here. Let's plug in -6, because that is right next to the asymptote, vertical asymptote. So -6 squared minus 9 over -6 plus 5, -36 minus 9 over -1, -36, -45 over 45. Oh, whoops, not -45. Wow. 36 minus 9 is 25 over -1, or -25, which is right there. So we'll continue in plugging a few more points. Let's plug in we'll plug in -12 and -16. So -12 squared minus 9, -12 plus 5, 144 minus 9 over 6, -6, 7, which is -135 over -7, which is roughly -19.29, and that is about right here. And then 16, -16 squared minus 9 over -16 plus 5 equals -256 minus 9 over -11, which is 247 over -11, which is roughly -22.5. And that is roughly right here. So graphing this side would be looking something like that. And so the question asks, where is it increasing and decreasing to? So we found out the minimum was to the right of this asymptote, the minimum was -1, -2, And the maximum on the left side of this asymptote was -9, -18. So anything from -5 to -1 is decreasing. Going from there to there, which is the minimum. So, and then decreasing on this side of the asymptote would be anything from -9 to -5. And that would also be decreasing, which is from the maximum point all the way to the asymptote, which there's no line there other than the asymptote. So increasing, it would be anywhere on the right side of the asymptote, would be anywhere from the minimum, or -1, to infinity is increasing. So anything from the minimum and beyond is increasing. Anything on the left side of the asymptote for increasing, anything from negative infinity to the maximum, or -9, is increasing. So anything from infinity up to this point, the maximum, is increasing. And that's problem 6.